differentiation, which is 30% included in your end of term 2 final exams, pure mathematics. So I will try to cover all these 6 units within this discussion, and I will also solve the questions which are given in the review pack. So you can see chapter number 4 is 30% weightage. It has the questions may come in the final exam. So a student needs to know how to differentiate the exponential function, how to differentiate natural logarithmic function, how to apply the differentiation when the two functions are multiplying, how to apply the differentiation when the two functions are in the division form, in a quotient form, what is the differentiation of sine, cosine, and tan, and finally when the x and y variables are mixed together, like you have implicit differentiation. So let's start. Trigonometry, yesterday, I have already explained it to you in the revision session. Yeah. So let's try to solve all questions on exponential functions. But before I start, I just want to ask you, what is the, sorry, I wrote integration sign, derivative d over dx of ex. You all remember the derivative of e raised to power x is the same thing. Whatever you see, you just copy it as it is. This is the derivative of exponential function. Where the change happens if I give you some number outside, and if I do give you some power of this e, any 3x, which is an argument of an exponential function. So what is the derivative? I'll keep the coefficient as it is, and I will write the derivative of e raised to power 3x as it is, times the chain rule says I have to take the further derivative of 3x, which is 3. And the final answer comes to me 6e 3x. So that's the idea behind exponential functions. Let's start. The first question is y equals e raised to power minus 2x. So dy by dx, same answer. And the further derivative of minus 2x will be, yes, minus 2. And we can write it as minus 2 e raised to power minus 2x. That's the first answer. Okay, let me draw the lines here so that everything must be in front of you. The second question which I gave here, y equals e raised to power 5 plus x, then dy by dx. Can you guess? Shall I copy the same function, e raised to power 5 plus x? What is the further derivative of 5 plus x? The further derivative of 5 plus x is, the derivative of 5 is 0, and the derivative of x is 1. So this is 1. What's the final answer I will write? I'll write e raised to power 5 plus x. That's the final answer. Okay. Next. Third question. Third question, you can see it's y is equals to 9 e raised to power 3x. Now you have find dy by dx. The coefficient will stay as it is. Copy it. E raised to power 3x copy it. Now the further derivative of 3x is 3. So now this 9 and this 3 will be multiplied, and you write 27 e raised to power 3x. Let's go to the fourth question, which is the D. Let me write here D part. Y equals minus 8 e raised to power square root of x. Interesting. When I get the dy by dx, minus 8 as it is, e raised to power square root x as it is. Now we have to take the derivative of square root of x. You remember the radical sign, it shows its power is 1 over 2. You take the 1 over 2 back, and from the power, you subtracted 1. So same thing, I will do it here. 1 over 2 goes back, and from the power, you take off 1. Let us write the simple answer. This is minus 1 over 2. 2 cancel with 8, it gives you 4. So minus 4 e raised to power square root of x times x minus 1 over 2. If you want to bring it down, so you can write minus 4 e square root of x over square root of x if you want it. Otherwise, there is no need. D, and then we go to the e part. Y is equals to 3 e raised to power x minus 2 e raised to power 4x. Take the derivative. Now we have two terms where we have to apply the differentiation. 3 as it is, e raised to power x as it is. Further derivative of x is 1, no need to write. Minus 2 as it is, e raised to power 4x as it is. The further derivative of 4x is 4. Okay, so my final answer comes to me 3ex 2 times 4 is 8 e raised to power 4x. Let's go to the f part. Y is equals to half e raised to power minus 8x. So if you want to get dy by dx, half as it is, e raised to power minus 8x as it is. The further derivative of minus 8x is minus 8. Can I cancel 2 with the minus 8? It is minus 4 e raised to power minus 8x. That's all for this. This is final answers. Let me draw the line. Okay. Okay, guys. Now we are doing the G part. The G part he gave to us y is equals to e4x minus x dy by dx. Same answer. Further derivative of 4x is 4. Same answer. Further derivative of minus x is minus 1. So we could write e raised to power 4x minus this minus and plus will be minus e raised to power. This is dy by dx. Done. Come to the h part. Y 6 e raised to power minus x minus 4 e raised to power 3x. So dy by dx, 6 is a coefficient, stays. Copy e raised to power minus x. Further derivative of minus x is minus 1, then minus 5, copy, e raised to power 3x, copy, further derivative of 3x, which is 3. Now simplify. This 6 and this minus 1 multiplied together gives you minus 6. This minus 4 and 3 multiplied together, minus 12. And that's the final answer. I part, he wrote y is equals to e raised by x plus 2 and e raised by x minus 1. We cannot do differentiation unless we open the brackets. Now, e raised by x times e raised by x, when we multiply them together, it is e raised by 2x, because look, ex multiply with ex, same basis, powers will be added. So x plus x is 2x. That's why I wrote ex times ex is e raised by 2x. Then we need to multiply ex with minus 1. So it will give me minus ex. Then I need to multiply this to ex. Then plus 2 multiply with minus 1 is minus 2. So y is equals to e raised by 2x. Now, can I simplify them? Yes, it has minus 1 at the back. So plus 2 minus 1 is just plus 2, plus 1. 1 e raised by x minus 2. Now apply the differentiation dy by dx. Same answer. Further derivative of 2x is 2. Same answer. And the derivative of minus 2 is 0. I may write dy by dx is equals to 2e2x plus e raised by x. Let's solve the last question, last 3 questions, I think, of this type. And then you will have a complete command on exponential functions, inshallah. These 3 questions might be a little bit complicated. J part, y equals 2e 3x minus 1 whole squared. Now we need to multiply the brackets together. Can I write it 2 times e raised to power 3x before applying the differentiation? 3x minus 1. Now multiply. Come on. This multiply with this. Yes. 2 times 2 is 4. E raised by 3x times e raised by 3x is, you remember what I did? I need to add the power 3x plus 3x is 6x. Then this multiplied, it gives you minus 2 e raised by 3x. And then minus 1 multiplied gives you minus 2 e raised by 3x. And then minus 1 times minus 1 is plus 1. So y is equals to 4e6x minus 2e3x minus 2 3x minus 4e3x plus 1. I'm ready to apply the differentiation, boys. dy by dx, coefficient as it is, 6 e raised by 6x as it is, further derivative of 6x is 6 minus 4 as it is, e raised by 3x as it is, the further derivative of 3x is 3, and then the plus 1 is 0. Let me write my final answer. dy by dx, 6 times 4 is 24, e raised by 6x, 4 times 3, 12, e raised by 3x. And that's my final answer. Now go to the A part. A part. Y equals 1 plus e raised by x over x. We cannot apply differentiation. First, we need to split the terms. 1 over e raised x plus e raised by x over e raised by x. Can I push this denominator to go in the numerator? So then the power will change its signs, minus x, and ex cancel with the ex, it will give you 1. Now I'm ready to apply the differentiation. dy by dx, e raised by minus x will be the same thing. Further derivative of minus x is minus 1, and the derivative of 1 is 0. So dy by dx, it is giving us minus e raised by minus x. That's the final answer. Last part, L. Y is equals to e raised by minus 4x plus 2 plus 7 e raised to power 5 minus 2x. Now dy by dx, ready? Copy the same expression, e raised to minus 4x plus 2. Further derivative of minus 4x plus 2 is just minus 4. Then plus 7 as it is, e raised to 5 minus 2x as it is. Further derivative of 5 minus 2x is, you remember 5 is 0, and the derivative of minus 2x is minus 2. Now simplify minus 4 first, e raised to minus 4x plus 2, and then minus 2 times 7 is minus 14, e raised to 5 minus 2x, and that's all. So guys, you can see I have solved all the questions which are based on exponential functions. Now I'm switching to the next concept. I think there is one application problem I have added in exponential functions. So why not we can do this? He said find the exact value of the gradient of a tangent. You remember gradient means finding dy by dx. So actually he's asking us to find the dy by dx of this expression. And then in the dy by dx, we will substitute 1 in the place of x. That gives us the gradient of a tangent at 1. So let's start. So y is equals to e raised by x minus 6 x raised by 1 over 2 is the given function which is provided here. I'm ready to apply the differentiation dy by dx. Remember ex same answer, minus 6 same answer. Now you need to apply the power rule of differentiation. The power goes back, and from the power you will subtract 1. So dy by dx, as it is, 2 cancel with 6, it gives you 3, and x half minus 1, you can do it on calculator or mentally, it will be minus 1 over 2. Now, did he provide us the value of x? 1, substitute it. So dy by dx, it is also called gradient. So e raised to power 1 minus 3, 1 raised to power minus half. So my friends, I got e minus 3, power of 1, anything you can check on the calculator as well, it will be 1. And what is my final answer? E minus 3. Shall I calculate the decimal value? No. He mentions here, find the exact answer. So in the exact answer, you need to keep your e minus 3. This is my final answer. The next question number 3 is related to logarithms. So for logarithms, boys, you need to recall what I have taught you. Bismillah. What I have taught you in logarithmic functions. So let us revise. Whenever I want to find the derivative of natural log, so the derivative of the natural log is I need to reciprocate my argument. It is x over 1. I have to write 1 over x. So this is the differentiation of ln of any argument. Whatever the argument you have, you just reciprocate it. Further derivative of x is 1. We don't write, and then the final answer is 1 over x. Suppose if in the exam I ask you derivative of ln of 2x. Wow, ln of 2x. What I need to do? First, I want to hit at what is the derivative of ln? The derivative of ln is reciprocate my argument. This is 2x. So I'm going to write it as what? 1 over 2x. Then the further derivative of 2x is what? That is 2 in the numerator. So 2 cancel. Again, the answer is 1 over x. Sometimes examiner give you a question like that. ln of 3 minus 2x raised to power 5. Now don't try to take the derivative and don't try to write it like this, 1 over 3 minus 2x raised to the power 5. No. Just go back and think. ln has a very special property. What is that property? If you have a power on the argument, then this power first shifted back and it becomes as the coefficient of ln before applying the differentiation. So that's why I'm keeping the d over dx here. I'm bringing 5 back, 5 ln. Imagine now the question becomes so simple. Now 5 will stay as it is because it is the coefficient. Now what is the derivative of ln? Reciprocate this, 1 over 3 minus 2x. Now what is the further derivative of 3 minus 2x? The further derivative of 3 minus 2x is minus 2. Can I simplify? Now this 5 is going to multiply with minus 2, gives you minus 10 over 3 minus 2x. That's the final answer. I hope it clears to everyone. Now we are ready to jump into the solving of question number 3. So please, your notebooks must be in front of you and keep solving with Mr. Omar. That is the reason I am solving every question. So your pace and my pace should match and we will finish all the questions. So question number 1, I'm going to copy it. Y is equals to 8 ln of 3x. Ready? dy by dx. 8 will stay as it is. Now, what is the derivative of ln? Reciprocate your argument. Now, what is the derivative of 3x further? 3. Can I cancel 3 with the 3? So my dy by dx comes to me 8 times 1 is 8 over x. That's the final answer. Next, I'm going to go to the b part. Y is equals to ln of 2x cubed. Here maybe the students thinking, Mr. Omar, we can take this 3 back. No. Don't do this because this 3 is not on the whole argument. If the question was like this, 2x power 3, then you are allowed to take the 3 back and then you write it as 3 2x. But this mistake, don't do this. Okay. Now you have to take the derivative of ln. So ln tells you reciprocate your argument, 1 over 2x cubed. Now the further derivative of 2x cubed, it is 2. Come on. 2x cubed is 3 times 2, 6. 6x squared. Cancel 2 with the 6, it is 3. And x squared cancel with x cubed, it gives you x. So dy by dx in a simplified form is 3 over x. Let's go to the c part now. Y is equals to ln of 2 minus 4x. So dy by dx. Okay, first apply the differentiation of ln, which is the reciprocation of argument. I did it. Now times, what is the derivative of my argument? Derivative of 2 is 0, no need. Minus 4x is minus 4. So in a beautiful form, I'm going to write it as minus 4 over 2 minus 4x. If any student wants to simplify it and divide 2 with every term, he can do that. But I am just leaving it like this. Next question. Next question is after doing C and now D. We have a D part. Y is equals to 6 ln of x over 2. Be careful in this part. We have to find dy by dx. 6 is a coefficient, copy. Ln, reciprocate. So 2 goes up, x goes down. You understand? I reciprocated x over 2, which is 2 over x. Now the further derivative of x over 2 is, come on, x over 2 is just half because x over 2 means half x. So half will stay as it is and the derivative of x is 1. So x over 2 derivative gives you half. Now may I cancel 2 with the 2? And then I get my final answer dy by dx equals to 6 over x. Now we go to the E part. In the E part, he give us y is equals to ln of a big radical sign on the argument 2x plus 1. My friends, first of all, you need to know this radical sign means what here? It's a square root sign, yani power 1 over 2. The important thing here now, the power is on the whole argument. So I'm ready to apply the property of ln before applying the differentiation. So half goes back ln of 2x plus 1. Let's apply differentiation now. Half ln means reciprocate your argument, and then the further derivative of 2x plus 1 is just 2. Can I cancel, my friends, 2 with the 2? And my final answer comes 1 over 2x plus 1. E, and then we go to the F part. In the F part, y is equals to ln of 5x whole power 10. I can apply the power property. The 10 goes back. 10 ln of 5x. Now I'm ready to apply differentiation dy by dx. 10 as it is, coefficient. ln means reciprocate your argument. And then the further derivative of 5x is 5. Now 5 cancel with 5. I will get dy by dx. It is equals to 10 over x. Then we go to the G part. Y is equals to ln of 3ex minus 2x. Now dy by dx. ln tells you reciprocate your argument. Further derivative of e raised by 3x. Come on, guys. E3x is 3, ex as it is, and the angle is x. Yani argument is x, or derivative of x is 1, no need. Minus 2x derivative is minus 2. Wow. So in a beautiful form, I will write it as 3ex minus 2 over 3ex minus 2x. That's all with it. G is done. Now we go to the H part. H part, he says y is equals to 9 ln of x squared plus 3x whole squared. So what happens, guys? This square goes back. I'm going to apply the power property of log. So 2 goes and multiply with 9. It makes it 18 ln of x squared plus 3x. And now I'm ready to apply my differentiation. So 18 is a coefficient, stays. ln tells you reciprocate your argument, x squared plus 3x, and that the further derivative of x squared plus 3x is 2x plus 3. Now, dy by dx will be equals to 18, 2x plus 3 over, no need to multiply 18 inside the bracket. So x squared plus 3x. We are done with this. Now, after doing the h part, I'm going to go to the I part. In the I part, he says y is equals to 5 ln of 7 minus 2 over x. Wise, I think we can easily solve it. But before this, I want to write this 2 over x in a new form. Let me write it, and then you see. 7 minus, I want to write, because here the power is 1. When I push it to go up, it becomes minus 1. Now it's ready to be differentiated. Dy by dx. Okay, 5 is a coefficient, stays. ln means I need to reciprocate. 1 over 7 minus 2 x raised by minus 1. Further derivative of 7 minus 2 x raised by minus 1. 7, the derivative of 7 is 0. Minus 2, and this minus 1 comes back. So minus 2 times minus 1 is plus 2, and x raised by minus 2. So here you go. This 5 is going to multiply with 2. It gives you 10 x raised by minus 2 over 7 minus 2 x raised by minus 1. So no need to do further simplification, and that's all with the I part. Now I'm going to go to the J part. So the J part says y is equals to 4 ln of a big radical sign x squared minus 8x. Now this tells you we have to write this radical in a power form, x squared minus 8x. we are allowed to use the power property of log. So 4 times 1 over 2 ln of x squared minus 8x. Cancel 2 with 4, so y is equals to 2 ln of x squared minus 8x. I'm ready to apply the differentiation, dy by dx. 2, reciprocate your argument, so x squared minus 8x, and then the further derivative of x squared minus 8x will give you 2x minus 8, and then I'm going to write dy by dx as 2x minus 8 over x squared minus 8x. That's all with our answer. Right, boys? We have a k part left and l part left. So k part is y is equals to ln of e raised to power 5x. You may use the property. What is the property? Power property. This 5x goes back. I'm going to write y is equals to 5 ln of e. And also the x goes back. Wow. And guys, ln of e, beautiful. ln of e, ln of e, that is always equal to 1, because when the base and the arguments are same, answer is always equal to 1. So before applying the differentiation, I just left with 5x because that thing is equals to 1. So what is the derivative of 5x? dy by dx, that is just 5. Very good. I love this question. Last part, k and l. L part, y is equals to ln of 7 over x plus 6 whole power x plus 3 whole power 6. Can I push this to go up? So y is equals to ln of 7x plus 3 raised to minus 6. I'm ready to apply the differentiation. Now, please, 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 guys, again, don't say, Mr. Romer, send the minus 6 back. No, there is a 7. Its power is 1. So the argument is not having, the whole argument is not having a power minus 6. So I cannot take minus 6 back. So what I'm going to do, guys, be careful. I'm going to apply the differentiation. What is the differentiation? Reciprocate your argument. 1 over 7 x plus 3 raised to minus 6. I reciprocated it. Now, what's my next procedure? Next procedure is derivative of this whole thing. 7 is a coefficient. I kept it. Then minus 6 goes back. The chain rule, you remember? The minor yani. I want to find the derivative of x plus 3 raised to minus 6 and 7. So 7 comes as it is. This minus 6 to apply the power rule. Minus 6 goes back and minus 6 minus 1 and keeping x plus 3 as it is. And the further derivative of x plus 3 is 1. So I'm going to copy here. So minus 6 is back. And from the power, I take off 1 and x plus 3 kept as it is. Further derivative of x plus 3 is 1. So can I cancel 7 with the 7? dy by dx. This can go up. And it will be written as x plus 3 raised to power 6. And this is minus 6. And what is this? This is x plus 3 raised to power minus 7. Guys, allow Mr. Romer to combine x plus 3's. So this is minus 6, x plus 3, 6 minus 7, because the same basis I have. So minus 6, x plus 3 raised to power minus 1. In a beautiful form, you can write minus 6 over x plus 3. So it was a good question, and it has taken lots of algebraic skills from you. That's the final answer. 5 is the final answer. And this is final answer, final answer, final answer. I hope, guys, you understand all the questions which I did for ln functions. Clear? I put one question. You try. This is the application problem of ln. So I have find the turning point. Turning point means I have to get the dy by dx first and put it equals to 0. Copy the function. I'm gonna find dy by dx. This is 1. The derivative of x is 1 minus ln x is 1 over x, and put it equals to 0. Then send 1 over x to the other side, and then cross multiply. So x will give you 1. He's asking for the coordinates. You need to substitute it into the original equation to get the corresponding y coordinate. Guys, you can check ln of 1 is 0. So y is also 1. I got x is equals to 1 and y is equals to 1. Now determine whether it's the maximum point or a minimum point. So the maximality minimality is found by finding dy by dx, any the second derivative. So second derivative I'm gonna find now. So my first derivative is what? 1 minus, I'm sending it up so that it looks like dy by dx is 1 minus x raised to minus 1. So the derivative of 1 is 0. Minus 1 comes back, becomes plus 1. X raised to minus 2. This is 1 over x squared. Now substitute the value of x, which we have found in by putting dy by dx equal to 0. Now see what is the final sign I'm getting. 1 over 1 squared. It is giving me 1, and 1 is a positive number. The rule tells us if the second derivative is positive, it means this point is a minimum point. Which point? 1, 1. 1, 1 is a minimum point of a curve. Now, boys, we are ready to jump into the product rule. Before I start explaining the product rule, you need to recall what did we study in product rule. If you have UV, and that is also given in MF19, keep the U as it is, take the derivative of V, and then V as it is, take the derivative of U. That's the product rule. So there is one question on product rule in the exam, so you need to practice it thoroughly. So let's start with the questions. Question number 1. A part, y is equals to x dot ex. Now imagine this is u and this is v. I'm ready to find dy by dx. I'm making the two boxes. Ready? Here is u. This is v prime, v, u prime. So can I copy u as it is? X. What's the derivative of vx? Same answer. What is v? E raised to power x. What's the derivative of x? It is 1. My final answer is x, ex plus ex. That's all with it. And let's go to the B part. Y equals 4x minus 1 and x squared minus 1. Although I can multiply the two brackets, it is easy for me to do the differentiation. And after simplifying it, apply the differentiation. But now, as I'm practicing u-v method, so I will call this one as u and this one is v because they are the two brackets are multiplying. Ready? So how do we do the dy by dx? Dy by dx, I'm gonna get the two boxes. U, v prime, v, u prime. What's the derivative of 4x? 4x minus 1 as it is. The derivative of v prime is just 2x. V is x squared minus 5. And the derivative of 4x minus 1 is just 4. So I'm getting 2x, 4x minus 1 plus 4, x squared minus 5. If you want to simplify it, 8x squared minus 2x 4x squared minus 20. 8x squared plus 4x squared is 12x squared, and minus 2x minus 20. That's the final answer for this product rule question. Next is C part. Y is equals to x squared square root of x squared plus 1. Now I'm doing the differentiation, applying the product rule. Two boxes. Split them into two parts. U, V prime, V, U prime. This is U and this is V. What I'm gonna do here, guys, I'll copy x squared as it is. So I need to apply the derivative of this thing. So it has a power 1 over 2. I will bring the power back. And from the power, I subtracted 1. So this is power rule. Keep x squared plus 1 as it is. Don't forget in chain rule to take the further derivative of x squared plus 1, which is 2x. Now what is my V? Square root of x squared plus 1. And the derivative of x squared is just 2x. Now this 2 cancel with this 2. And this x multiply with this x squared, and it gives you x power 3. And x squared plus 1 raised to power minus 1 over 2 plus 2x square root of x squared plus 1. We can simplify it furthermore if you want it. Otherwise, if examiner didn't mention it, you can stop it here. But I will do it further. Bring it down. So when you bring it down, its power becomes positive, and I am going to write them in a radical form. You may stop here. If you want to write it as a single fraction, you can write x squared plus 1, because here we have 1. And this is x cubed multiplied with 1 plus 2x. When both of them multiply, it leaves you x squared plus 1, because square root of x squared squared plus 1 times square root of x squared plus 1 is just x squared plus 1. And then finally, you open the brackets. So x cubed plus 2x cubed plus 2x. But again, I'm saying it is needed only when examiner wants you to get this form. 2x4, sorry, 2x3 3x3 plus 2x over square root of x squared plus 1. So you may stop here or here. Next question, A, B, C. I'm going to go to the D part. The D part, he gave y is equals to square root of x and ln of x. I'm going to call it as u, and this is v. So dy by dx, square root x as it is. Derivative of ln of x is 1 over x plus then ln of x as it is. A derivative of square root of x. The 1 over 2 goes back. From 1 over 2, you subtracted 1. So what Mr. Omer did, u, v prime, v, u prime. Can I simplify them? So x, 1 over 2, this is 1 when I push it to go up with minus 1, plus ln of x over 2, x raised to power minus 1 over 2. So this is x raised to power minus 1 over 2. This is ln of x. Bring it down to square root of x. Also, you can bring it down 1 over square root of x plus ln of x over 2 square root of x. If you want to write it as a single fraction, so times with 2 times 2 square root of x. So 2 plus ln of x. If a student wants to stop here, no problem. Here is also the answer. The D part, then I'm going to go to the E part. E part is y is equals to x squared 2x plus 5 whole power 7. Apply the product rule. Y x squared as it is. The power rule, please don't forget the power rule. 7 goes back. And from 7, you subtracted 1, it gives you 6. Further derivative of 2x plus 5 is 2. So that's the v prime plus v as it is. The derivative of u is 2x. Now why? Sorry, I found the dy by dx. I forgot to write it. Can I simplify? 7 times 2 is 14 x squared and 2x plus 5 raised per 6. And here it is 2x plus 5 raised per 7. If a student wants to stop here, no worries, but I can see something is common. Okay, guys, so see the common things. I'm going to take 2 common, x common, and 2x plus 5 raised per 6, the smallest power. I took it common. So what is left here? 7x along with 7x just. Here, 2x is gone, so just 2x plus 5 left. So 2x plus 5 raised per 6, 7x plus 2x is 9x and plus 5. That's all with this answer. After E, I'm going to take you to the F part. F part is y is equals to square root of x minus 3 whole squared. So this is u and this is v. So dy by dx, u as it is. Apply the power rule. 2 goes back. X minus 3 raised by 1. Further derivative of x minus 3 is 1. No need to write. Plus x minus 3 whole squared. Apply the power rule on square root of x because we want to take the u prime. 1 over 2 x raised by minus 1 over 2. Now this will become 2 square root of x minus 3 and plus x minus 3 whole squared over 2 square root of x. I think we need to leave it here. No need to further solve because the basic product rule is practiced. Guys, after that, G part, y is equals to e raised to power 2x. Very important for the exam point of view. We have u. This is v. dy by dx. E raised to power 2x as it is. The derivative of 4x plus 1 is 4. Then 4x plus 1 as it is. The derivative of e raised to power 2x is, we keep the same answer as for e, but the further derivative of 2x is 2. 4e 2x plus 2e 2x and 4x plus 1. You can leave the answer here, but I would love to take e raised to power 2 e raised to power 2x common. What is left inside? 2 plus 4x plus 1, and then it gives us 3 plus 4x. Then we go to the h part. The h part, y equals x plus 3 raised by 4. This is my u, this is my v. So dy by dx, x as it is. Apply the chain rule or the power rule. 4 goes back. X plus 3 raised by 3. And the further derivative of x plus 3 is 1. No need to write it as. Plus v prime, v as it is. V as it is. And the u prime, which is 1. Is there anything common in the two terms? I think x plus 3 raised by 3 is common. So what is left to me here? 4x. And here is x plus 3 left. And then dy by dx. So x plus 3 raised by 3. And this 5x plus 3. That's the final answer for H. Now I part, which might be the last part in the product rule. So y is equals to x squared ln of x. Now dy by dx, chain rule, u and v. I'm going to write here x squared as it is because it's u. What is the v prime? Ln of x is 1 over x. And then v as it is, u prime, which is 2x. Cancel x with this one. So x plus 2x ln of x is the final answer for this particular question. If you want to take x common, you can take x common as well. But it's up to you. So guys, I have practiced with you the product rule in details. Now we go to the application part. Find the equation of a tangent. So equation of a tangent can be found. First, we need to find the dy by dx, which will give us the gradient. So let's try dy by dx. This is u and this is v. So u as it is, v prime 3 goes back. And from the power, we take off 1, which becomes 2. Further derivative, don't forget 1 plus x squared. The further derivative is 2x plus 1 plus x squared raised by 3 as it is, and the derivative of x is 1. Now dy by dx, 2x and 3x will become 6x squared because they're outside the bracket. 1 plus x squared raised by 2 and 1 plus x squared raised by 3. Now boys, what is the value of x given to me? 2. So I'm going to substitute here 2 dy by dx. Basically, it is my gradient 6 2 squared 1 plus 2 squared whole squared plus 1 plus 2 squared whole cubed. Simplify this one 24. This is 4 plus 1 5 squared plus 5 raised by 3. Let me simplify it. 24 times 25 plus 125. So it gives you how much, guys? 725. So gradient is 25. I have the x coordinate, but I don't have the y coordinate. Substitute the value of x here. 2 1 plus 2 squared raised by 3. Let's see what the answer comes to us. So 2 bracket open 1 plus 2 squared. Close the bracket, raised to the power 3. It gives me 250. So my point is x coordinate 2 and the y coordinate 250. I'm ready to find the equation of a tangent line. Y is equals to mx plus c. Y is 250. And tangent gradient 725. X is 2 plus c. Let's try to calculate from the calculator. 250 equals 725. Bracket open 2, close, plus x, shift, solve, and I got minus 1200. So c is equals to minus 1200. So what is the equation of a tangent I have found? Y equals 725x minus 1200. That was the question. Now, guys, we reach to the quotient rule. Let me revise. What was the quotient rule we studied? The quotient rule is when you have u over v. There is one question coming in the exam on quotient rule. So v squared, and copy the v as it is. Now u prime. In the product rule, you were having a plus sign. Now you have minus sign in between the two terms. Now u dot v prime. So don't forget, guys, this is the quotient rule we have to apply in the questions. The first question. Now, A part, he tells us y is equals to 2x over x plus 3. Ready? So this is my u and this is my v. Let me write the formula here, dy by dx. What is that? V squared, v dot u prime minus u dot v prime. Are we ready to apply the quotient rule? Yes. What is the denominator? X plus 3, put a square on it and copy x plus 3, which is v. What is the derivative of u prime? The derivative of 2x is 2 minus copy 2x. And what is the derivative of x plus 3, which is 1? Now simplify 2x plus 6 minus 2x over x plus 3 whole squared. Cancel 2x with minus 2x. And the final answer comes to us 6 over x plus 3 whole square. And that is my dy by dx. First question is done on quotient rule. Now let's do the B part. The B part, he gave you y equals e raised to power 2x over x. Let's try. This is my u and this is my v. Let me write the formula again. Dy by dx, denominator squared, then denominator u prime minus u dot v prime. So dy by dx, whatever the denominator, you put a square on it, put the denominator term as it is. What is the derivative of e raised by 2x? Same thing, but further derivative of 2x is 2 minus e raised by 2x as it is. The derivative of denominator x is 1. So we can simplify e raised by 2x if you want to take common, or you want to keep it as it is. 2x e raised by 2x minus e raised by 2x over x squared. I think leave it here because nothing will be cancelled from the denominator. Let's go to the C part now. C part is y is equals to x squared over x plus 4. Now I'm going to apply the quotient rule, dy by dx. So put a square on the denominator and x plus 4. Numerator's derivative is 2x minus denominator's derivative is 1. So dy by dx 2x squared plus 8x minus x squared. I opened the brackets, x plus 4 whole squared. And finally, I got dy by dx as x squared plus 8x over x plus 4 whole squared. That's all with my final answer. Guys, now I'm going to go to the the E part. No, A, B, C, now D part. The D part is y is equals to x over 1 plus x squared. So dy by dx, denominator under the square, then again denominator, derivative of x is 1 minus x, derivative of 1 plus x squared is 2x. Open the brackets. Simplify the numerator. And that's the final answer. Now go to the E part. Y is equals to 3x over 2 minus x. On the brackets. Minus 3x times minus 1 is plus 3x. That's the final answer. F part. Under the square. Derivative of numerator is 6x. Two ex as it is, minus 1. Open the brackets. 12x ex 6x squared 6x squared e of x plus 3x squared over I think they can be simplified. Minus 6x squared plus 3x squared is minus 3x squared. I think no need to simplify it further because x is, I think, common, but leave it here. So what did we do? We finished the f part. Now we go to the g part. I think the space is left. I'm going to solve it here, the g part. Y is equals to 3x minus 4 over 2x plus 1. Numerator's derivative is 3. Denominator's derivative is 2. Open the brackets. And please make sure that minus sign is outside. G part is done. Now we go to the H part. Square of the square, any power 4. Derivative of 3x plus 5 is 3. Then 3x plus 5 as it is. By the chain rule, 2 goes back. X plus 1 raised by 1. The further derivative of x is 1, no need to write. Simplification. No need to open the square. Just keep 3 outside. Here, if you allow me, otherwise, student can open the brackets. I can see here x plus 1 whole squared and x plus 1 is common. So I'm going to take x plus 1 common. What is left inside the bracket? 3 along with x plus 1 minus 2, 3x plus 5. This whole depends upon your algebra skills, guys. So x plus 1 cancel it and leave you 3. Open the brackets. Make sure there is a minus sign outside. That's the final answer. So just I have applied here some algebra properties. You can look into it. I 6x squared over 2 minus x squared. Derivative of 6x squared is 12x. And then 2 minus x is minus 1. On the brackets. I have 24x. I think it's better to leave it here. I part is done. Now I'm going to go to the J part. Four x over 1 minus x whole power 3. Square of the 3, and 3 times 2 is 6. The derivative of 4x is 4. Chain rule. The derivative of 1 minus x whole power 3 goes back. 2, and the further derivative of 1 minus x is minus 1. Minus 1 and this minus becomes plus 4, 12x over. Can I take common? If I take common 1 minus x whole squared, what is left inside? 4 plus 4 1 minus x. I think it's better to take 4 outside. So only 1 minus x will be left here, plus 3x over. Cancel this, and it leaves you 4 here. Again, guys, I'm telling you, he's hitting at your algebra skills. So J part done. Now I'm going to go to the K part. Y is equals to x squared plus 1 over x minus 2. Two x, the derivative of numerator. Derivative of the denominator is 1. Open the brackets. Make sure there is a minus sign. It changes all the signs. And that's the final answer. I'm going to go to the L part, which is the last part in quotient rule. I hope after doing all these questions, you will have a complete command on quotient rule. Denominator, put a square, and ln of x. Derivative of 5x squared is 10x minus 5x squared. And the derivative of ln of x is reciprocate your argument. X cancel with x. So 5x left on the top. I think stop it here. Very good. So what we did, we practiced all the quotient rule questions. There is one question left here. I put it for you, which is the application part, equation of a normal. He gave you this question. Let's do the derivative. I will try to do here. So dy by dx, 2x minus 1 whole squared, 2x minus 1, derivative of the numerator, 6x, and the derivative of denominator is 2. Put it equals to 0 because I want, oh, not equal to, I'm not finding stationary point, guys. Sorry for that. I just need to simplify this. Open the brackets. 12x squared minus 6x minus 6x squared over 2x minus 1 whole power 2. Simplify 6x squared minus 6x over 2x minus 1. Can you substitute 2 to get your gradient of a tangent? I'm going to substitute here. Fraction 6, bracket open, 2 squared minus 6, bracket open, 2, and down 2. brackets I put here 2 minus 1, and I get my answer 4. So this is the gradient of a tangent. Gradient of a normal, just change the sign and reciprocate it. So minus 1 over 4. He's interested in the equation of a tangent line. Y is equals to mx plus c. I want to get c. Y coordinate is 4. Normal is minus 1 over 4. X is 2 plus c. Let me try to get the value of c. 4 equals minus 1 over 4. 2 plus x. Shift solve. C is 4.5. 4.5. So I got c is equals to 4.5. So what is the equation of a normal line? Y equals to minus 1 over 4x plus 4.5. That's the equation of a normal line for this particular question. So I did it over here, so let me shade it. Students know that this part is provided here. Now we go to the derivatives of sine and cosine. Let me explain you the derivative of sine x is cosine of x given in MF19. Derivative of cosine x is minus sine of x, and the derivative of tan of x, which is in your course, secant square of x. Before I start doing, I have just make you familiar about the formulas. So I'm ready to apply the differentiation on trigonometric functions. First question, a y is equals to sine of 5x. So dy by dx, derivative of sine is cosine, argument as it is. Further derivative of argument is 5. So my answer is 5 cosine of 5x. Let's go to the b part. Y is equals to 6 tan of x over 2. So dy by dx, 6 as it is. Derivative of tan is secant square x over 2. Further derivative of x over 2 is 1 over 2. So 2 cancel with 6, leaves you 3 secant square x over 2. C part, y is equals to cosine of x squared plus 2x. So dy by dx, cosine is minus sine. Keep the argument. Further derivative of x squared plus 2x is just 2x plus 2. Leave it here. Next part, d. Y equals 4 tan square of x. Be careful, we have to apply the power rule here. Dy by dx, 4 as it is. Power goes back. From the power, you subtracted 1. Then the further derivative of tan, which is secant square of x. Then the further derivative of x, which is 1. I'm going to combine them, dy by dx, 8 tan x secant square of x. After doing the d, I'm going to go to the e part. Y equals sine of x cubed minus 7. So dy by dx, derivative of sine is cosine, argument as it is. Further derivative of argument is 3x squared. I can leave the question here. E and then f. Y is equals to 5 tan of 4x dy by dx, 5 as it is. Derivative of tan is secant square. Keep the argument, and the further derivative of argument is 4. So dy by dx in simplest form 20 secant squared 4x. That is the f part. G, y is equals to cosine of cube x Don't forget, you have to apply the power rule. Power goes back. From the power, you take off 1. Further derivative of cosine of x, which is minus sine of x. Then further derivative of x, which is 1. So dy by dx comes to be minus 3 cosine square of x and sine of x. Now we go to the h part. Y is equals to sine of 2x and cosine of x. Did you see we have a product rule? Apply the product rule. U as it is. What is the derivative of cosine of x? Minus sine of x, any v prime, plus. Now keep the v as it is. What is the derivative of sine 2x, which is cosine 2x times the further derivative of 2x is 2. To write it in beautiful form, minus sine of 2x, sine of x plus 2, cosine of x and cosine of 2x. H is done. I'm going to go to the j part. No, there is an I part also. Y is equals to x squared tan of 3x. Again, product rule. Dy by dx, leave x squared. Derivative of tan 3x is secant squared 3x. Further derivative of 3x is 3. Plus tan of 3x. And the u prime is 2x. If you want to write it in simplified form, so this is 3x squared secant squared 3x plus 2x tan of 3x. I is done. Now we go to the j part. Y is equals to cosine of 2x. Now we can use the quotient rule. This is u and this is v. So dy by dx, whatever I have seen the denominator, put a square on it, then x squared. The derivative of cosine of 2x is minus sine 2x. Further derivative of 2x is 2. Then minus sine, write the u as it is. The derivative of denominator x squared is 2x. So dy by dx in simplest form minus 2 x squared sine of 2x minus 2x cosine of 2x over x power 4. If you want to take x common, dy by dx, x common, so minus 2x sine of 2x minus 2 cosine of 2x over x power 4. Now x cancel with x power 4, it gives you 3. So dy by dx, it is minus 2x sine of 2x minus 2 cosine of 2x over x power 3. Okay, so this is your final answer. What is left? J is done. K part and L part. K and L part. So let's do the K part. K part is y is equals to sine cube 3x and cosine of x. I need to apply the product rule. Sine cube 3x as it is. The derivative of cosine of x is minus sine of x plus cosine of x as it is. Apply the power rule. 3 goes back. 3 sine squared 3 of x. Further derivative of sine is cosine of 3x. And then the further derivative of 3x is 3. So minus sine cube 3x sine of x plus 3 cosine of x. 3 times 3 is 9. I'm going to get 9 sine of x sine square 3 of x and cosine of 3 of x. You cannot do further simplification. Leave it here. Now I will solve the last part here in this empty space. L part I'm talking about. Y is equals to 4 tan of square root of x. Ready? So dy by dx, this is 4. Derivative of tan is secant squared. Keep the argument as it is. Now the further derivative of the argument is half goes back from the power, you take off 1. Now 2 cancel with 4, it gives you 2. So dy by dx, it is equals to 2 secant squared square root of x, and this is x raised to power minus 1 over 2. And I can write it as dy by dx is equal to 2 secant squared square root of x over square root of x. That's the final answer. Now, show that the second derivative is this thing. I have this expression. So y is equals to ln of square root of cosine of x. First, may I use the power property of log? Yes. So half goes back ln of sine of x. Taking the derivative dy by dx, 1 over 2. Reciprocate your argument. 1 over cosine of x. Further derivative of cosine of x is minus sine of x. So I'm going to write dy by dx as minus sine of x over 2 cosine of x. Boys, you remember that sine x over cosine of x is tan of x. So I'm going to write it as dy by dx is equals to minus half tan of x. I'm ready to take the second derivative now. So d squared y over dx squared minus half is a coefficient. What is the derivative of tan of x? That is secant squared of x. Is it the same thing which I want to get? Yes. So this is done. Now we go to the implicit differentiations. Implicit differentiation, what I have taught you guys in the class, whenever we have the mixture of x and y terms, you apply the implicit differentiation. You need to understand the derivative of x with respect to x is always 1, but the derivative of y is with respect to x is just dy by dx. You cannot do anything. But if you are taking the derivative of y squared, just apply the power rule first. So 2y, and then the further derivative of y is dy by dx. But in the case of if you want to find the derivative of x squared, you simply say 2x. You remember you apply the power rule and then you take the further derivative of x, which is 1, you don't write it. But when you take the derivative of y power 3, you write 3y squared and then further derivative of y, which is dy by dx, which is not 1. That's why you have to write it. So is it okay, guys? Let's start with the implicit differentiation. I'm gonna write the first question on implicit differentiation. First question, A. X squared plus 2y minus y squared is equals to 5. The derivative of x squared is lovely, 2x. The derivative of 2y is 2 dy by dx. The derivative of y squared is, come on, apply the power rule, 2y, and the further derivative of y is dy by dx, and the derivative of 5 is 0. Now what you need to do, you have to combine, yani take dy by dx factor, okay, and send the other term, which is without dy by dx, on the right hand side. So I'm going to take dy by dx common. So 2 minus 2y left within the brackets, and 2 plus 2x goes to the other side, becomes minus 2x. Now this bracket is multiplying here. When you send it to the other side, it will be divided. So dy by dx is equals to minus 2x over 2 minus 2y. That's the final answer for this implicit differentiation. B part, x cosine of y plus is equals to y squared plus x. Now here you can see we have a UV method. You need to apply the product rule. So leave x, the derivative of cosine of y is minus sine of y. The further derivative of y is dy by dx. Boys, don't forget it. I'm taking the derivative of cosine of y. The cosine gives you minus sine of y, and the further derivative of y is dy by dx. Then plus cosine of y as it is, and the derivative of x is 1. Now, what is the derivative of y squared, which is 2y dy by dx, and the derivative here for x is 1. Let's try to combine minus x sine of y dy by dx and plus cosine of y is equal to 2y dy by dx. Send this expression to the right hand side. You're left here with cosine of y. So 2y dy by dx plus x sine of y dy by dx. Now dy by dx is common. So when you take it common, guys, so cosine of y 2y minus x, plus x sine of y dy by dx. Now this bracket is multiplying and goes to the other side. Cosine of y over 2y plus x sine of y is equals to dy by dx. Important question, so please focus on it. Now we go to the next part, which is the C part now. C part, y is equals to 5. Oh, first time inverse tan came, and I think we did not discuss about the derivative of inverse tan. No worries. So the derivative of inverse tan of 3x, guys, its formula is given in MF19. This is 1 over, come on, 1 over 1 plus x squared. Whatever the argument you have, you write it here under the square. So 3x whole squared. Then the further derivative of 3x is 3. I'm gonna get 3 over 1 plus 3x whole squared is 9x squared. So please, guys, work on it. The derivative of inverse tan 3x. In the formula sheet, it is written derivative of inverse tan of x is 1 over 1 plus x squared, like this. Now, dy by dx, 5 as it is. Apply the derivative of inverse tan, which is 1 over 3x whole squared. Further derivative of 3x is 3. So dy by dx given to us 15 over 1 plus 9x squared. We got to go to the d part, which is x cubed plus xy squared is equals to 5x. Now the derivative of x cubed is 3x squared. Here is UV method. Don't forget, you have to apply the UV method. What is the UV method? The product rule. The product rule is you write here x as it is. The derivative of y squared is 2y. Further derivative of y dy by dx. OK, this is the derivative of y squared. Then plus leave y squared. The derivative of x is 1. And then minus 5x equals 5x. The derivative of 5x is 5. So 3x squared plus 2xy dy by dx plus y squared is equal to 5. Keep the dy by dx term here on the left and send the remaining terms on the right hand side. Now 2xy was multiplying. I want to isolate dy by dx. So 5 minus y squared minus 3x squared over 2xy. That's the final answer for this. Now I'm shifting towards E part. E part is x squared plus y squared is equals to y. The derivative of x squared is 2x. The derivative of y squared is 2y dy by dx. And the derivative of y is dy by dx. Send this one to the right hand side. So 2x is equals to dy by dx is equal to minus 2y dy by dx. Now take dy by dx common. So once you take dy by dx common, 1 minus 2y, and then you have 2x over 1 minus 2y is equals to dy by dx. That's the answer. E part is done. Then F part. In the F part, he says 2xy minus 3y is equals to y squared minus 7x. What's the, can I apply the product rule here? So 2x as it is, the derivative of y is dy by dx. I'm applying UV method. UV method. Okay. Now plus y, the derivative of 2x is 2. So product rule done. Minus 3 dy by dx. And then y squared is 2y dy by dx. Minus 7x is minus 7. Try to combine all the dy by dx terms. Take dy by dx common. Now dy by dx minus 7 minus 2y over 2x minus 3 minus 2y. If you find lots of minuses, you can change their signs as well, but this is my final answer. Okay. Now I go to the G part. G part is x ln of y is equals to 1 plus x. Now apply the product rule. X as it is, the derivative of ln y is reciprocate y, and then the further derivative of y is dy by dx. Plus, then ln of y as it is, the derivative of x is 1. On the other side, the derivative 1 is 0, and the derivative of x is 1. So x over y dy by dx plus ln of y is equal to 0. Since I want to find dy by dx as a subject, send it to the right-hand side, minus ln of y. So dy by dx is equals to cross multiply, so minus y ln of y over x. So finally, dy by dx has been made as a subject. I think last part here, h. H, y equals e raised by x inverse tan of x. Lovely. It's a product rule. U and v. So dy by dx, ex as it is, inverse tan of x derivative is 1 plus x squared. Further derivative of x is 1, no need to write, plus inverse tan of x as it is, derivative of ex is ex. I'm done. If you want to write it in a beautiful form, you can write like that, but that's all fine. Right, boys? So let's go to the next question. Question number 12. We need to prove it's an implicit equation, right? So let's try to do this. ln reciprocate the argument, further derivative of the argument, we need to apply the product rule, x dy by dx, and then y, the derivative of x is 1. Why, as you understand, first I hit at ln, which reciprocated the argument, and the further derivative of the argument, unfortunately, that was a product rule. So I applied u v prime plus v u prime. I did it. And then the x squared is 2x, and this is y squared 2y dy by dx. Will you allow me to send this dy by dx on the other side and multiply with them? So I'm left with x dy by dx plus y, and 2x becomes 2x squared y because xy is multiplying with it, and this becomes 2y squared along with x dy by dx. Now I need to combine all the dy by dx terms, send it to the right and send this one to the left. So y minus 2x squared y, and here is 2y squared x dy by dx minus x dy by dx. And then I'm taking y common, so 1 minus 2x squared. And here is 2y squared minus 1x dy by dx. Right? Can I send it to the other side? So y 1 minus 2x squared divided by x 2y squared minus 1 is equals to dy by dx. I think this is the final answer, but if there is a change of signs, you can change the signs, guys. It's allowed. You can change the signs to make the same result as what he got. Dy by dx is equals to y. So plus 1 becomes minus 1, and minus 2x squared becomes 2x squared. And then I will write here 1 minus 2y squared. Okay, guys. So up till now, what we have covered, we finished with the questions on differentiation. Now integration started. Inshallah, I will make another video for it. Thank you, guys. Assalamu alaikum wa rahmatullahi wa barakatuh.